Hi everyone, I think by this time I can probably say good afternoon, but only by a minute. So I'm Madlen, for those of you who haven't met me before. I'm based here at Tocal College, working with DPI as part of my role. I'm also actively involved in research and mostly in the space of honeybee nutrition, floral resources, pollination. And today I'll be talking about Varroa and honeybee nutrition and how those two are pretty closely linked. So I think right now many of us are asking ourselves the questions like what has actually changed, like what do we need to do different now that we are facing Varroa, and probably many of you are already actively monitoring or treating for Varroa at this stage. And in the space of honeybee nutrition, well, in some ways not a whole lot has changed, but the answer is also yes, it has. And why I say that is that in terms of the nutritional requirements of honeybees, nothing is very different as such. So they still have the same nutritional needs in terms of having access to nectar as the source of carbohydrates, because they use it as a fuel of energy. They need it to be able to produce wax. In terms of the requirements for pollen, they need it as their major source of all other nutrients. So it is their resource for protein, for fats, minerals and vitamins, and I'll go into that a little bit later on. But I think the challenge that we have now is where earlier on, even if the nutrition was not quite as optimum, like, yeah, we could get away with it, but that is certainly changed now. So we need to really stay on top of managing honeybee nutrition because of the impacts that Varroa is now also having on the bees. And we'll talk more about that as well. So just as a quick reminder, Varroa is a parasite of honeybees. So that means that it is an organism that lives in or on an organism of another species. So in this case, the honeybee, and benefits by deriving nutrients. So the bottom line is there's no benefit for honeybees at all. The Varroa mite gets in there, 100% relies on development stage of honeybees to reproduce, and essentially takes all the nutrients it needs from honeybees. So keeping that in mind, what do Varroa mites actually feed on? What do they eat? And the answer is they mostly eat fat bodies or fat body tissue. And we usually, or many of you might have heard those two terms before, where we talk about the reproductive phase and we talk about the phoretic phase. So Varroa mite can feed on developing brood or larvae, and it can also feed on adult honeybees. That's what we refer to as the phoretic phase of the mite. And we'll talk about the impacts of Varroa feeding on both life stages of our phases shortly. So when we talk about fat bodies, like where do we actually find fat bodies? What do fat bodies do for honeybees? So what you can see in the image on the right is actually, if you imagine a bee abdomen cut into half, so it's a cross section, and in that image, where you can see all that fat body tissue, that is of a bee that is feeding off good nutrition. So that bee has stored excess nutrients in the abdomen, and you would find that specifically in nurse bees. So they are the ones that feed all colony members. They are the ones that Varroa like to feed on, and they feed on that tissue. Quite often people refer to fat body in honeybees in human terms. It would be equivalent to our liver, if you like. Because the fat bodies for honeybees, they are involved in not only nutrient storage, and there's a large part of protein that bees can store in fat bodies, but it also is involved in border regulation, detoxification, plays a role in the immunity and the immune system. So it really is a crucial part. So if you can imagine having this little parasite, or in comparison for human terms often referred to the size of a dinner plate, or a rabbit sucking the nutrients out of your liver, yeah, maybe not. So that's what happens in honeybees. The image on the very right, you can see a comparison to a bee that is poor, has a poor diet, doesn't have the nutrients, doesn't have big fat body stores. Now, Varroa is very difficult to spot, and there's a good reason for that, because they are very opportunistic. They like to get onto the bee on the underside of the abdomen, and the reason being is because that's where the highest concentration of fat bodies are. So they specifically, that was mentioned earlier as well, like to slot into the third segment of the underbody, because not only is that where the area is highest concentrated with fat bodies, but it's also the biggest pocket where the mite can hide from the bees trying to groom themselves and trying to flick those mites off their bodies. So it's a hiding spot, but it's also the best place for them to actually feed on the fat bodies of bees. So how do Varroa mite actually feed on honeybees? If you think about any kind of insect, whether it is honeybees, whether it is mosquitoes, in this case a mite, they have very specialized mouth parts so that they can feed on the food resource that they're feeding on. So for the mites, they in some ways have a very simple gut structure. So it's more or less just like a tube. There's no special digestive enzymes in their gut that they can use to digest food. And that really limits them to not being able to digest any solid food, but they have to feed off liquids. So what they do instead is they have mouth parts that pierce through the first tissue. They get to the fat bodies, and that's an adult bee. And then they inject digestive enzymes into the fat body tissue, which then the fat body tissue starts breaking down inside of the bee. So it kind of creates a slurry, or kind of like a smoothie kind of substance. And they then use their mouth parts, which sort of forms like a straw, you can imagine it, and they can then suck up that liquid inside of the bee and use those nutrients. So it's very clever, very simple at the same time. And you can see electron micro, what's it called? A very high resolution image of the mouth parts on the right there. So the impacts on larvae and developing pupae, there's many of them reported in the literature, but we know that the effects on adult development, there's quite a few of them. So for one, bees that are parasitized during development, they have a decreased body weight as adults, and we know that that also leads to reduced lifespan later in life, so that can have a big impact. Deformed wings, so quite often you hear people talk about a deformed wing virus, which causes the wings to shrivel up in bees. It doesn't always have to be as a result of the virus. So if you see shriveled up wings, it might simply be because of the mite feeding on the pupae during development, and then it causing deformities when they develop as adults. So there can be different reasons why we might see deformed wings. Pupae that has been fed on by Varroa, they also tend to have smaller hypopharyngeal gland and mandibular glands. Those are the glands that nurse bees need to develop in the very early life stages to be able to produce jelly and brood food. So the capacity of those bees can be reduced as well to feed future brood. We have an obvious loss of body protein simply because the mite is feeding on them. This is also a time where mites can transfer viruses. And in drones, there's also an impact on their emergence rate and also on their fertility, such as their sperm count. Similar in adult bees, we have impacts on their reduced immunity, as you were saying. Fat bodies play a big role in immunity, reduced lifespan, also the foraging of the honeybees is impacted, and they show a reduced tolerance to pesticides as well. And again, that can also be a point in time where viruses can be transferred from the mice to the adult bees. But I want to spend a little bit of time talking a little bit more about viruses, because I think there's a lot to it in some ways. So viruses can not only be passed on between the mites, from the mites to the bees, but also once the viruses are there in the colony, the bees there's so many of them, they are in contact all the time. They're transferring viruses between individuals while they're feeding brood and so on. And globally speaking, there are more than 20 different viruses that affect honeybees. Not all of them are in Australia, and this is an example of deformed wing virus that we currently haven't detected in Australia. With viruses, just like with bacterial or fungal infections, or even pests for that matter, they can vary from season to season and also from year to year. So if you sometimes experience higher or lower levels from year to year season, that's to be expected. Now, these are just some examples of some of the viruses that are around globally, and the ones that have previously been detected in Australia, which are highlighted in the light orange there. And the ones that have an asterisk behind them, I hope you can see that on the screen, they have been identified to be transferred, or that the mite can transfer those viruses. So people have found those viruses to be linked to mites being able to transfer them. So I'm not going to go into the detail of the different viruses, but deformed wing virus and acute bee paralysis viruses are definitely some of those viruses that we hopefully will not detect or do not want to detect in Australia. But yeah, it's going to be a little bit of a mission. Now, the effects on colony from Varroa as a whole, it really depends on the level of infestation. So for that reason, we obviously want to keep the mite levels low and below the threshold levels. It also depends on secondary infestation. So any disease or anything that's having an impact on honeybees, whether can be from moving hives, can be from nutrition, can be from other diseases, it is stressful for the colony. And suddenly we're adding another level, the mite, into the mix. So you can imagine what impact that can have on the colony. Now, the impacts of Varroa on the colony can also depend on climate and also on food source. And obviously, the more mites, the bigger the damage. But for now, I will continue to focus more on the nutrition and food side of things. So honeybees do have, as I mentioned before, nutritional requirements that they need to meet. If there's especially any essential nutrients, as we know for amino acids have been studied the most, if they don't get those essential amino acids from their diet, they simply cannot produce them from precursors or other amino acids by themselves. So they really rely on it from the environment. This is an image of our research house where we are continuously trapping pollen to see what the bees are bringing in, and then analyze that pollen for their nutritional quality. So as a rule of thumb, you really want to see 3 different pollen colors coming into the hive at any point in time, which gives you some confidence that the bees are foraging on different floral resources, which will provide different nutrition for the bees. Because as you can see here, the protein content, for example, in pollen varies very widely, like 7%, which would be the lower end, is what you could expect in, for example, wind-pollinated species, and then others are more average around 25, and right up to 35% or even greater. Same for fat. Fat can vary quite a bit within plant species in the pollen, and same for minerals and vitamins. So this is just an example to show you how different the pollen can really be within only a few months or within a period of time. So this is pollen that we've trapped from April through to July and August, and even just looking at the pollen colors, you can see how different they are. But what I want to bring your attention to is also the quality in the pollen, because you have, on one hand, you've got the quality, but you also have the quantity. So different species produce different quantity of pollen, but also different quality. And one example of a pollen that's very high in protein is, for example, broadleaf tea tree or Melaleuca quinquenervia. In terms of its fat content, we don't actually quite know how much fat it has, even though we have a large database in Australia, really, of pollen species. So we are actually ahead in that space compared to other countries. There's still pollens where we need to know a lot more about. Fireweed, on the other hand, or any plant species part of the daisy family, so it could also be capeweed, dandelions, they're usually orange in color, and they are very high in oil content, which attracts the bees, but in terms of protein, they are a poor source of protein for honeybees, and they also lack some essential amino acids. In terms of white clover, it's pretty much your good average pollen. It's got average amount of protein, same for fat, and yeah, the bees can do quite well on it. Just in terms of what's flowering right now, so in this area we've got bees are working ironbark. There's quite a few different species of ironbark, but it's an example of a species that can be providing a good amount of nectar, but the pollen can be of limited resource for honeybees. And yeah, just another point to keep in mind is also that many eucalypt species have been found to be low in isoleucine, which is one of the amino acids. So that's just where you want to see a variety of pollen for the bees. So what are some of the signs that a colony has access to good nutrition? And some of the most obvious ones is if they're storing excess food resources. So you definitely want to see that the bees are storing nectar in the form of honey. You also would like to see some pollen, ideally different colors in this case, stored around the brood or on the outside frames within the brood nest usually. And you want to see that you have brood in all different stages. So you want to be able to see eggs, developing larvae, uncapped brood, and capped brood, so that you know that you've got an active laying queen, the queen has the nutrition she needs to be able to lay eggs and so on. But at the same time, if you get used to looking at your brood boxes, as was mentioned earlier, you can also pay attention to how much jelly the larvae is actually being fed, because it will give you an indication as to how much nutrition is around. So if you see the larvae really almost like swimming in jelly, you can be reassured that there is good nutrition for the bees and they're really looking after the next generation. Another indication that the bees are on good resources is that there are drones around. If there are no drones in your colonies, it could either, well, the colony might also not have reached that stage yet if it is a very small colony, but a honeybee colony will only raise or keep the drones going in the hive if the resources are there, because they consume a lot of food. Coming back to Varroa and mite treatments, so we now rely on treating for Varroa and actively managing it, whether you choose to use organic or synthetic treatments. But at the end of the day, any treatment is also stressful for the hive. And if you now have poorly fed bees, or you have bees that have nutrition that they need, and you add another stressor in the mix, I think the answer is clear which colony or which bees will be better off. So if it's just like for us, if we are on a good diet, we're not as susceptible to disease or to getting sick, and bees are no different. So well-fed bees, and we also know this from research that has been done, where people have looked at hives in the same area, that were affected by Varroa. They looked at the virus levels inside of the hives, and some of the hives that they nutritionally supported by supplementary feeding pollen. And they were feeding them in autumn and looking how the bees come out in springtime. And they found that those hives were much better, the ones that were nutritionally supported were much better at overwintering. And even though the virus levels were no different, Varroa levels were very similar, but they just had a much better immune system, and that carried them through winter time as well. So yeah, well-fed bees also have a longer longevity, better at brood rearing, and in the end of the day, they also handle the Varroa treatments much better. What can we do to support bees? Number one, learn about floral resources and how good or how much pollen or nectar they produce. So there is the Honey and Pollen Flora of Southeastern Australia, written by Doug Somerville. Same for fat bees, skinny bees, which will tell you a lot more about supplementary feeding when it is needed, if that's something that you would like to do some more reading about. Also, just quickly want to bring your attention to this report that was only published last week, so you can download that as a PDF online. I was working together with a colleague of mine based down in Wagga, but we actually had 4 different sites spread around New South Wales where we looked at pasture species and their value to honeybees. So we've looked at mostly clover species, but if you are interested in planting anything specific for bees, that would be a good one to have a look at. And lastly, I just want to share some photos. So that's our apiary site that's located 2 hours north from here, where we're looking at the costs and benefits of supplementary feeding. So on a regular basis, we trap pollen, we look at how many frames of bees, what's the population like, what's the health of the colonies, and look at how can we supplementary support the bees and what are really the costs and benefits in doing that when it is needed, either could be for commercial beekeepers when they want to build the hives for crop pollination, or in those periods of times where we might have a pollen or nectar dearth. So yeah, thank you everyone. Are there any questions?